All right, in this section, we're going to talk about rational functions and using a method that is called the partial fractions. All right, this is something you should have been covered in algebra. For example, the example we're going to look at first is we have a polynomial over a polynomial. And we want to integrate it. But unfortunately, we can't use any of the properties we know so far. Because if we try to make it an ln, the bottom is x squared minus 2x minus 3, the derivative would be 2x minus 2, which is not that. So since there's no connection there, what we have to do is this is when we're going to rewrite the equations into a form that we can integrate them much easier. So first thing you do is try to factor out the bottom if possible. So we have x and x, opposite signs. What times what is 3? When you subtract them, you get 2, and a bigger number. So it's minus 3 and positive 1. So to integrate, we need to find the partial fractions. And the partial fractions is that we're going to recreate the numerators in terms of the denominator and the numerator, the coefficients. So if we're going to integrate this, we have our equation. Since we have linear factors on the bottom, our denominators are going to be each one of those separately. All right. So what we have to do now is we have these equations. We have to figure out what A and B are in reference to this factor. The way we do this is we're going to have to use matrices. So in order for these to be equal, here are your steps. Since we have fractions and an equal sign, find the LCD. The LCD is always this term because that's where it came from. That's where these guys came from. So multiply the LCD to each term. So this is a term, this is a term, and that's a term. So we have x plus 1, x minus 3 times 5x minus 3, x plus 1, x minus 3, x plus 1, x minus 3 times a over x minus 1 plus x plus 1, x minus 3 times b x minus 3. Third step, reduce. in other words, cancel what you can. So both of these cancel with both of those. So we get 5x minus 3. The x minus x plus 1 cancels. So we have a x minus 3. The x minus 3 cancels. So we have b x plus 1. Multiply to remove the parentheses. We have ax minus a3 plus bx plus b. Now solve. All the x's, we want them together. So ax plus bx, and all the constants, they'll be together. So it's 3a plus b. So we have, factor out the x, we have a plus b minus 3a plus b. Each other. So set the coefficients. So we know that 5 is equal to a plus b. And then the negative 3 is equal to negative 3a plus b. So 5 equals a plus b. Negative 3 equals negative 3 plus b. Now we have a system of equations. We can multiply the bottom one by negative 1. So negative 1 times 3 is 3, 3a, negative b. So the b's cancel, so I have 8 equals 4a divided by 4. A is equal to 2. Since a equals 2, I could plug it back in the first one. So I have 5 equals a plus b. A is 2. Subtract 2. So b is equal to 3. So back to our intervals. We had 5x minus 3 over x plus 1 x minus 3 dx equals a over x plus 1 dx plus integral of b x minus 3 dx. Substitute a and b in there. A is 2. We have 2 x plus 1 dx. 3 x minus 3 dx. That's a constant. So I have 1 over x plus 1 dx 3, 1 x minus 3 dx. The integral of, well, that's u, that's du. So we have the integral is the absolute ln of the absolute value of the denominator. Ln x minus 3 plus some constant. That's how we use partial fractions to find them. All right, and on your example sheet, I write down the rules. General description of the method. Success in writing the rational function f of x over g of x as a sum of partial fraction depends on two things. First one, the degrees of f of x must be less than the degree of g of x. The degree here is 1, the degree is 2. So that one, we know it's going to work there. If it isn't, then do long division and only work with the remainder. Then we must know the factors of g of x. Any polynomial with real coefficients can be written as a product of linear factors and real quadratic factors. In practice, the factors may be hard to find. And here they are. The denominators, x minus r, be linear factors of the denominator. And suppose that your denominator factors had, this is a multiplicity, is the highest power of that. It divides g of x. So if we have a multiplicity for our denominator as after it's factored, then we have to keep on writing the x minus r squared, all the way until we get to what that multiplicity is. So if we had multiplicity 3, we have x minus r squared, x minus r cubed. And then we'd solve for the numerators. If your denominator is irreducible, you can't go any further, so it has no roots, then we have to leave the number alone, but this time we'll have a binomial in the numerator. Again, and it all depends on the multiplicity of those quadratic factors. Set the original fraction. Set the original fraction equal to the sum of those partial fractions. And that's what we're going to talk about. We set them equal, and then we have to solve for the numerators. Equate the coefficients and corresponding powers of x, and solving the resulting equations in undeterminate coefficients. So let's look at example 1. Again, this method is not difficult, it's just long. So example 1. And you have to remember how to do your either Cramer's rule or how to solve matrices. X squared plus 4x plus 1 over x minus 1, x plus 1, x plus 3 dx. All right, so if we look at the first one, we notice that the degree of the numerator is 2, and the degree of the bottom is 3. So it matches the first condition. So we use partial fractions. We have x squared plus 4x plus 1, x minus 1, x plus 1, x plus 3 dx. Since we have three distinct linear factors, we're going to have three integrals. So we set our numerator, which is x squared plus 4x plus 1. Because now we have to set them up and get rid of the denominators. So our LCD is this. And if we multiply the LCD to everybody, all of these cancel. So we have x squared plus 4x plus 1. X minus 1 cancels. So we have x plus 1, x plus 3. In the second one, the x plus 1 cancels. So we have an x minus 1, x plus 3. In the third one, the x plus 3 cancels. So we have an x minus 1, x plus 1. Get rid of the fractions. Now we got to solve A, B, and C. So multiply those out. We get x squared plus 4x plus 3. X squared plus 3 minus 1 is plus 2x minus 3. And this is the difference of two squares, so it's x squared minus 1. Distribute, get rid of the parentheses. So we have 4x squared, ax squared plus 4ax plus 3a. Same thing with this one. Get plus bx squared plus 2bx minus 3b plus cx squared minus c. Now group them. So we have the ax squared, bx squared, cx squared, plus 4ax, 2bx, there's no c, plus 3a minus 3b minus c. So x squared is made up of a plus b plus c. The x's are made up of 4a plus 2b. And the constants are 3a minus 3b minus c. So now since we have x squared, then we know that the 1 has to equal to the a plus b plus c. The coefficient 4 has to equal that coefficient, 4a plus 2b. And then the constant 1 equals to that whole thing. 3a minus 3b minus c. All right, so let's look at all these. Let's transfer this onto the page. So we have 1 equals a plus b plus c. 4 equals 4a plus 2b. And 1 equals 3a minus 3b minus c. Solve using matrices. I like to use Cramer's rule. In Cramer's rule, to find the x, y, z's, or the coefficients of x squared, x, and the constants, I take dx over d. This one's dy over d. And this one is dz over d. So I take the first, I have to find d. So it's the determinant of the coefficients here. So it's 1, 1, 1, 4, 2, 0, 3, -3, -1. Because this is the A column, this is the B column, this is C column, this is equation 1, 2, 3. This is x squared, this is x, and this is constants. The way you do this if you have 3 by 3s is take the first, write down the equations, and then recopy the first 2 columns, take these and put them at the back. So we have 1, 4, 3, 1, 2, -3. Okay, I just took these and then repeated the first 2 columns. Now I take these diagonal rows are diagonals. I multiply them. So 1 times 2 times -1 is -2. 1 times 0 is 0 times is 0. 1 times 4 is 4 times -3 is -12. So now these, I got to do it in reverse. So I subtract these. I'll subtract and I multiply all these. -1 times 4 is -4. -3, so it's 0. 3 times 2 is 6. So I multiply all those, add them together. So here I have -14 minus 2. My d value is -16. So that's going to be on the bottom. -16. Now I got to do the same thing with x, y, and z. The dx, instead of the x column, this x, y, z, instead of the x column, I put the answers. And leave, so these will go in the first column. So I have 1, 4, 1. Leave the other 2 alone. So it's 1, 2, -3, 1, 0, -1. Copy the first 2 over. And do the diagonals again. So multiply these, you get -2 plus 0 minus 12 and subtract these. So multiply all these together. So 1 times 2 is 2 plus 0 minus 4. This is -14 minus -2 is -12. So this is my dx. Ooh, I'm sorry. So I multiply these. So 1 times 2 times -1 is -2 times 0 times -12. Add them, subtract. Now multiply these. -4 plus 0 plus 2. Add those, subtract the 2. This one minus this one. I get -12. So that's dx, -12. Four goes in both of them, so it's 3/4. So my x, the first one, or this is the a, do the same thing. For my dy, here's my x, y, and z. So now for the dy, I take the answers and put them in the second column. So I got a 1, 1, 4, 3. Now the answers are 1, 4, 1. And then the last column, 1, 0, -1. 1, 0, negative. Copy over the first two, 1, 4, 3, 1, 4, 1. Multiply each of these diagonals, then add them together. So it's -4 plus 0 plus 4. Multiply these together. 3, 4 is 12 plus 0 minus 4. So that becomes 0. 0 minus 12 minus 4 is 8. It equals -8. So dy is -8. dy is -8. So I come here, dy goes up here. Negatives cancel. 8 divided by 16 is 1/2. So my b value is 1/2. Now I'm going to do for my c value. Again, for the c value, I leave the first two alone, put the answer in the third. So this is dz, which is take the first one, leave it alone. Take the second one, leave it alone. Now put the answer in place of the third one. Repeat the first two columns. And repeat. Multiplication, 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 then add up all those. 1 times 2 is 2, is 12, is -12. Now I subtract these. So that's 6, -12, and it's +4. So the 12s cancel, so we have 2 minus 10 minus 12 is -2. So dz is equal to 4. So dz is 4. Makes it negative 1/4. All right, so I have A equals 3/4, B equals 1/2, and C equals negative 1/4. I plug those back into here and then take the integrals. So I have the integral of x squared plus 4x plus 1, x minus 1, x plus 1, x plus 3 dx equals A is 3/4 over x minus 1. B is 1/2 x plus 1 dx. And then negative 1/4 x plus 3 dx. That's a constant, so I could bring it out in front. That's a constant, I could bring it out in front. And that's a constant, I could bring it out in front. It's a negative 1/4. The integral of 1 to du over u makes it ln x minus 1 plus 1/2. This is ln absolute value of x plus 1 minus 1/4 ln absolute value of x plus 3 plus c. And there's my integral. All right, let's look at another one with a different format this time. Okay. Example 2. Example 2 says, use partial fractions to evaluate all right. So basically what it's asking us to do, since this is a factored form, it's in binomials and it's squared, that means you're going to have two denominators. So what I'll be looking for is a over x plus 2 to the first. And it's x plus 2 to the second. So this is what I'm looking for. So what I have to do is I have to solve for a and b. X plus 2 squared equals a x plus 2 plus b x plus 2 squared. The LCD is always this one, so it's x plus 2 squared. If I multiply each of these terms by x plus 2 squared. I will get rid of the fractions and I'll be able to solve for a and b. So those cancel, so I have 6x plus 7. One of these cancels, so I have ax plus 2. Both of those cancel, so I have plus b. I have ax plus 2a. So I group them. So the coefficient of x is 6, and that equals a. So I know a equals 6. And the constant numbers, 7 equals 2a plus b. Since I know a equals 6, I can solve for b that way. So b is equal to -5. So a is 6, b is -5. I just substitute that, so I'll have integral of 6x plus 7 over x plus 2 squared dx is equal to integral of 6x plus 2 dx plus b was -5 x plus 2 squared. Six is the coefficient. -5 is a constant, so it goes up in front. Now we integrate. 6. This is 1 over that, so I can make it ln x plus 2. Now, but this one is the same thing as x plus 2 to the power -1/2. Which I add 1, so it's -1/2 plus 1. Which makes it x plus 2 to the power 1/2 over 1/2. Oh, not 2. So it's 2. I'm sorry. It's not 2. It's -2. So if I add 1, I got -1, -1. So this integral becomes -x plus 2 to the power -1 plus c. I don't know where I have from. So the final answer is 6 ln x plus 2. Negative makes it a positive. 5 x plus 2 to the power -1 plus c, or 6 ln x plus 2 plus 5 over x plus 2 plus c. All right. So that's if we had a denominator that had a multiplicity. For the third example, I have this equation, 2x cubed minus 4x squared minus x minus 3 x squared minus 2x minus 3 dx. Remember, the condition was I had to have a larger exponent on the bottom. Since it's not, so I need to divide. So I have x squared minus 2x minus 3, 2x cubed minus 4x squared minus x minus 3. Only look at the leading terms. So what times x squared gives me 2x cubed? 2x. So 2x times x squared is 2x cubed. Positive times negative is negative. 2 times 2 is 4. X times x is x squared. Negative 2 times 3 is 6x. Change the signs and add. And bring down everything else. So this is the remainder. And that one I do nothing with. So we have rewrite our equation as the integral of 2x dx plus the integral of 5x minus 3 over x squared minus 2x minus 3. Yeah, so that one I leave alone since it's just now for this one, I got to factor it out if possible. So x and x, positive and negative, and the bigger than what times what is 3? When you subtract, we get 2, 3, and 1. So now I got to do with respect to that one. So 5x minus 3, x plus 1, x minus 3. X plus 1, x minus 3. Multiply each term by the LCD, which is x plus 1, x minus 3, x plus 1, x minus 3. simplify. So I got 5x minus 3. The x plus 1 cancels, so I have a x minus 3. The x minus 3's cancel, so I have x plus 1. Distribute. Regroup. So I know the 5 x has to equal a plus b. Negative 3 has to equal negative 3a plus b. So 5 is equal to a plus b. Negative 3 is negative 3a plus b. I can get rid of the b's because they're both positive b. By multiplying the second one with a negative 1. I got to change the sign. I do it across the board. So negative 1 times negative 3 is 3. Negative 1, negative 3 is 3a minus b. Add. I get 8 equals 4a. So a equals 2. And I use the first equation, so 5 equals a plus b, and a equals 2. So b is equal to 3. So back to the integrals. We knew we had 2x cubed minus 4x squared minus x minus 3 over x squared minus 2x minus 3 dx is equal to the integral of 2x, this right here, plus this one, factor out to this. So I have a over x plus 1 plus b over x minus 3. And we defined what a and b were. A was 2 and b was 3. So the integral of x is add 1 to the top and then bottom, so it becomes x squared. And this becomes ln x plus 1 ln x minus 3 plus c. And there's my answer. right. Let's look at example 4. Because these are all looking at the different possibilities of how the question could be presented to you. So, example 4. So we have negative 2x plus 4, x squared plus 1, x minus 1 squared dx. All right. Here, x squared plus 1 is irreducible. And it's a quadratic equation. And then this one, we have 2 linear ones. So what's going to happen is we're going to have one partial fraction for this one, and then 2 more for these 2. So we're going to have 3 of them. But for the first one, we have to have 2x plus 4 over x squared plus 1, x minus 1 squared dx. For this first one, we have x squared plus 1, so we have to have ax plus b. And now for these other ones, we're going to have c x minus 1, and then d x minus 1 squared. So we have to have 2 for that one for that. Those are the 3 we're going to deal with. So now we have to find A, B, C, D. 2x plus 4, x squared plus 1, x minus 1 squared is equal to ax plus b, x squared plus 1, x minus 1, x minus 1 squared. The LCD, again, it's always the original, so it's x squared plus 1, x minus 1 squared. Multiply it to each term. Ax plus b over x squared plus 1 plus 1. Let me do it. C over x minus 1 plus x squared plus 1, x minus 1 squared, d x minus 1 squared. All those cancel, so we have minus 2x plus 4. Those cancel, so we have ax plus b, x minus 1 squared, c x squared plus 1, x minus 1, x squared plus 1. So we have negative 2x plus 4. Ax plus b. This one becomes x squared minus 2x plus 1. FOIL these, we get x cubed minus x squared plus x minus 1. And we get dx squared plus d. So we have ax cubed minus 2x squared plus a2ax plus bx squared minus 2bx plus b. That's how pull that out. Cx cubed minus cx squared plus cx minus c plus dx squared plus d. So we have for x cubes, x squared, x, and constants. We have no coefficient for that, so it's 0. For x, we have negative 2, and then the constant equals 4. So all of these, ax cubed plus cx cubed we have negative 2ax squared plus bx squared minus cx squared plus dx squared. Ax minus 2bx plus cx b minus c plus d. Now we're going to solve for a, b, c, and d. The x's are gone now. So 0 equals a plus c. 0 equals negative 2a plus b minus c plus d. Negative 2 equals a minus 2b plus c. Yeah, because now all the x cubes, x squared, all those cancel. So the first thing I gotta start and get these. All right, so if we take this equation and this equation, because you're going to get b minus c equals d. So if we add those two together, well, let's subtract them then. If we multiply this one by -1, we get 0 equals -2a plus b minus c plus d. -4 equals -b plus c minus d. Those cancel, those cancel. So we have -4 equals -2a. Change the signs. So a equals 2. Now we also know that 0 equals a plus c. So c must be -2. So it looks like the third equation. This is from the first equation. Then look at the third equation. We have -2 equals a minus 2b plus c. A is 2. C is -2. So -2 equals -2b. Change it so b is equal to 1. And we can look at the fourth equation. 4 equals b minus c plus d. So 4 equals 1 minus -2. This changes to plus. So 4 equals 3 plus d. D equals 1. So a equals 2. B equals 1. C equals -2. D equals 1. Now I got to go back to the original equation. Back to the integrals. Here. We plug in A, B, C, and D. So -2x plus 4, x squared plus 1, x minus 1 squared goes ax plus b, x squared plus 1 dx. C x minus 1 dx. D x minus 1 squared dx. A, B, C, D. 2, 1, negative 2. 2, 1, negative 2, 1. Two x plus 1 over x squared plus 1. Negative 2 over x minus 1 dx. 1 x minus 1 squared dx. But this one, I can split them up. Minus 2, 1 over x minus 1 dx plus 1 x minus 1 squared dx. So with this one, I could split it up into two parts because it's a monomial on the bottom and a binomial on top. So this is u du. So this becomes ln. Okay, that could be never negative. So that stays that way. 1 over x squared plus a squared is inverse tangent of x minus 2 ln x minus 1, because that can be a negative. And this one becomes the integral of x minus 1 negative 2. So add 1. So it's negative 1. So it becomes a minus. This is minus 1. So it becomes 1 over x minus 1 plus c. A lot more writing than that's what takes the fun out of it. But that's as far as we can go, because we don't know what x is. Example 5. Use partial fractions to evaluate dx x squared plus 1 squared So we have 1, 2, 3 possibilities. So we have 1 x squared plus 1 squared dx. The first one is 1 over a over x dx. That's the first one. We have x squared plus 1. That's irreducible. So we have b plus c x squared plus 1. Then we have to have another one. So it's dx plus e x squared plus 1 squared. So we have 1 over x squared plus 1 squared, a over x, bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 squared. The LCD is x squared plus 1 squared. We have x squared plus 1 squared times 1 x squared plus 1 squared. 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 Now reduce, all those are gone, so I have 1. The x is gone, so I have a x squared plus 1 squared. One of those are gone, so we have bx plus c times x squared plus 1. So we have dx plus e times x. Okay, so this gives us x to the 4th plus 2x squared plus 1. X cubed plus x dx squared plus dx. I gotta do this. 1 equals ax to the 4th plus 2ax squared plus a. Bx to the 4th plus cx cubed plus bx squared plus cx. So x to the 4th is equal to 0. So we have a plus b x to the 3rd is also equal to 0 because we don't have it anywhere on this side. This is c x squared is also 0. That's 2a plus b plus d. That's also 0. So we have c plus e. We have a so we know that we begin that a equals 1. So 0 equals 1 plus b. So b is equal to -1. Now this one. 0 equals 2 times 1 plus -1 plus d. 2 minus 1 plus d. 1 plus d. So d is equal to -1. C is equal to 0. E is equal to 0 because of this one. Okay. Math bloodbath. So A is equal to 1. B was equal to -1. C was equal to 0. What was D? D was -1. And E was 0. Back to the integral. Dx x squared plus 1 squared is equal to this. Ax bx plus c dx. Bx plus c over x squared plus 1 dx plus e x squared plus 1 squared. Plug in the values. We have 1 over x negative x over x squared plus 1 negative x over x squared plus 1 squared. All right, so that's just straight up ln x. It has to be absolute values because we can't have negative down there. This negative goes out there. Du over u should be 2, so we're missing a 2, so we have to have a 1/2 out here. So it's 1/2 ln x squared plus 1. So here we use u is x squared plus 1. Du is 2x. Since we need 2x, we need a 1/2 out here. The negative goes out front. Okay. This is u squared du is -2x. So we have x squared plus 1 to the power -2. Add 1. So it's -1. So it changes to a plus. That's 1 over x squared plus 1 plus c. Ln absolute value of x minus 1/2 ln x squared plus 1 plus 1 over 2 x squared plus 1 plus c. Okay. This is ln, since it's subtraction, it's absolute value of x, and that's x squared plus 1 to the power 1/2 plus 1/2 x squared plus 1 squared, what is this one, plus c. ln absolute value of x, square root of x squared plus 1 plus 1 over 2 x squared plus 1 plus c. That was a pretty long one. All right, let's do one more. Example 6. Find A, B, and C of this partial expansion: x minus 1, x minus 2, x minus 3. All right. Let's first try like we've been doing. So multiply by the LCD, you get x squared plus 1 equals a x minus 2, x minus 3, x minus 1, x minus 3, x minus 1, x minus 2. X squared minus 5x plus 6, x squared minus 4x plus 3, x squared minus 3x plus 2. So x squared plus 1. So we have ax squared minus 5ax plus 6a, bx squared minus 4bx plus 3b, cx squared minus 3cx plus 2c. So for x squareds, coefficient is 1. So that equals a plus b plus c. X, the coefficient is 0. We have negative 5ax, negative 4b. Those are x's. Negative 3c. The constant is 1, so it's 6. A, 3b plus 2c. So we have 1, 0, 1. Coefficients of 1, 1, 1. -5, -4, -3. So the main determinant is 1, -5, 6. 1, -4, 3. 1, -3, 2. Copy the first two columns over. 1, -5, 6. 1, -4, 3. That's -8. -18. -15. Minus these. So that's -24. -9. -10. So it's -26, 36, 41. Minus 33, minus 43. So it's a +3. So D is 3. One, 0, 1. One, 1, 1. -5, -4, -3. 6, 3, 2. So for dx, I take the answer, put it in the first column. So I have 1, 0, 1. 1, -4, 3. 1, -3, 2. Copy the first two columns. So that's -8, -3, 0. That's 0. -9, -4. -11 minus -13. So dx is 2. Now dy. I take the answer and put it in the second column. So I have 1, -5, 6. The answer is 1, 0, 1. 1, -3, 2. Copy the first two columns over. And multiply these diagonals. 0 minus 18 minus 5. 0 minus 3 minus 10. -23 minus -13 is -10. So dy is -10. Zero, -18, -5, minus 0, -3, -10. That's -23 minus -13 Negative is positive. So for DZ, I take the answer, put it in the third column. So I leave the first two alone. I got 1, -5 and 6, 1, -4 and 3, and then 1, 0, 1. Copy the first two columns over. So it's -4 plus 0 minus 15 -5 plus 0 minus 24. That's -19 minus a -29. This becomes a positive. 29 minus 19 is 10. And from the other page, remember, D was 3. So our X, which is A, is dx over D, which is 2 over 3. B is dy over D, is -10 over 3. And C is dz over D, is 10 over 3. So we're saying that A equals 2/3, B equals -10/3, and C equals +10/3. Was correct. See it again. Now, checking my work again. 43 minus 41 is not 3, it's 2. So D is 2. So D is 2. A is 1, -5, 5. A is 1, B is -5, C is 5. That should be better. Careless errors. Okay, let's look at some other ways. Two more examples to look at. Other ways to find the coefficients. Another way is determine the constants that appear in the partial fractions is to differentiate first. So let's look at example 7. X minus 1, x plus 1 squared, no, it's cubed, which equals a x plus 1, b x plus 1 squared, and c x plus 1 cubed. So it says, the instruction for this says, find a, b, and c by clearing the fractions, by clearing the fractions, differentiating, and substituting x equals 1. X is negative 1. Because that's what our restriction of a domain is. That's the value we'll choose. So first I have to clear the fractions. So multiply the LCD is x plus 1 cubed. So that's going to give us x minus 1. A x minus x plus 1 squared plus b x plus 1 plus c. Here we're going to figure out the constant by plugging in x equals negative 1. So we have negative 2 equals 0 plus 0 plus c. So c is equal to negative 2. That's the constant. So now we go back to here. C is negative 2. Take a derivative. So this side becomes 1. So we have 2a x plus 1 times the derivative of the inside. Derivative of the inside is just b, and that's constant. So we have 1 equals 2ax versus negative 1. So that goes to 0. So b is equal to 1. So from this one, so this finds first derivative. Let's find the second derivative. Differentiate again. So we get 0 equals 2a. So a is equal to 0. So this equation. So our equation x minus 1 over x plus 1 cubed equals a x plus 1, b x plus 1 squared, c x plus 1 cubed. Zero, 1, -2. A is 0, b is 1, c is -2. So it gives us x minus 1, x plus 1 cubed. So it's 0 over x plus 1 plus 1 over x plus 1 squared minus 2 over x plus 1 cubed. So x minus 1 over x plus 1 squared equals 1 over x plus x cubed. And that's what we'd find A and B. Okay, the last one. Example 8. Find A, B, and C. X squared plus 1, x minus 1, x minus 2, x minus 3. A, x minus 1, B, x minus 2, C, x minus 3. This is here. By assigning numbers to x. So step 1, multiply by LCD, gives us x squared plus 1 equals a x minus 2 x minus 3 plus b x minus 1 x minus 3 plus c x minus 1 x minus 2. Because the bottoms are x minus 1, x minus 2, we choose x equals positive 1, positive 2, and positive 3. So when x equals 1, we get 1 squared plus 1. A is 1 minus 2, 1 minus 3, 1 minus 1, 1 minus 3, 1 minus 1, 1 minus 2. So these are gone. So we have 2 is equal to A, -1, -2. So A is equal to 1. Now when x equals 2, we got 2 squared plus 1, 2 minus 2, 2 minus 3, 2 minus 1, 2 minus 3, 2 minus 1, 2 minus 2. So that's 0, that's 0. So we have 4 plus 1. So we have 5 equals negative b. So b is equal to negative 5. And when x equals 3. 3 squared plus 1. 3 minus 2. 3 minus 3. 3 minus 1. 3 minus 3. 3 minus 1. 3 minus 2. 9 plus 1. That goes to 0. That goes to 3 minus 3 is 0. 3 minus 3 is 0. 2 times 1. So 10 equals 2c. C equals positive 5. So the original equation becomes x squared minus 1, the 3 factors. We have 1 over x minus 1 minus 5x minus 2 plus 5x minus 3. All right, that's it for that one. Have a good weekend, everybody.